Okay, so make sure that all your mics are muted. If you don't hear any feedback from your mics. Okay, so we are on Unit 6 and the topic is software quality management. So in this study unit, quality management is discussed in detail, as well as the quality management process which needs to be followed before a software is implemented. Before a software is operational, it should undergo some quality checks and quality control. This is usually done by the QA or quality assurance team. All software must meet certain standards of the organization, country, and international standards. The QA team checks the project deliverables, process documentation, and software quality attributes. A detailed explanation of why it is important to do quality planning is discussed in this study unit, as well as the importance of having standards in an organization which supports quality management are discussed in detail. So quality is something very important. If you are building something for people to use, the first thing you'll be asked, or the first thing you'll be judged on, is the quality of what you deliver. Okay, so quality is everything. It builds your reputation, and we use the term a lot, not just in software. In anything that we do, you go shopping for clothes, you're buying furniture, whatever. You always gonna question that aspect of, is this thing quality? You're gonna look at the price for it, and then you wanna ask yourself, is it quality, and is it worth buying? So the same thing applies to quality, and most of the time, the one way that you can actually ensure quality in software projects is by being compliant in terms of standards. Okay, building something according to standards is one way of doing it. Okay, but we'll talk about that later on in the lecture. So we'll cover the following learning outcomes: have a thorough understanding of quality management process and the importance of quality planning and during software development. Demonstrate a detailed understanding of the importance of standards during the quality management process and how those standards are used in quality assurance, and have a thorough understanding of reviews and inspections can be used to ensure quality management in a project. Okay, so when you talk about quality management, it's actually one of the project management body of knowledge areas, okay, along with the other ones such as human resource management and cost management and so forth. So quality management is there, and it must be something that is done from day one. You don't sprinkle it at the end of the project to say, okay, now how can we ensure quality? It's an approach that you take from day one. And they say that ensures that the software developed is fit for purpose, should meet users' expectations, it's efficient, reliable, delivered within a specified time and within the budget. Okay, so one of the main measures we use to actually measure whether a software is quality is by looking at what the user, remember that quality is based on the user, and if it meets the user's needs, then you say it is quality. But we also use other factors. We take other factors into consideration before we make this judgment, okay? And we're going to talk about these other factors. But the main thing is to ensure that we did not deviate from any plan. What was the plan? What was the proposal? What did we promise to deliver? What did we eventually deliver? So those are the important things when it comes to quality, okay? For example, if you go to a store and you're buying a shirt, okay, you're buying a shirt with a Nike logo on it. Because it's Nike and they have a reputation for quality, you want to expect certain things from that shirt. So when you actually buy that shirt and then you go home and you wash it for the first time and it fades, then your quality or your users or owners' expectations were not met. So that's the first thing. Besides the fact, does it fit? Is it the proper color? Besides all of those other factors, the main one is, were your expectations fulfilled? Okay, and There are several methods and techniques used to check and control the effectiveness of software. Quality management is conducted by a quality assurance team. So we need the team that is checking for quality to be as independent as possible to avoid this issue of bias. Because if you're asking the people that are building the software to check themselves for quality, people have their own beliefs when it comes to how things should be done. So you can't ensure quality there. So we need an independent team, and this independent team will give us an independent view of what was promised and what was eventually delivered. Quality management establishes the framework of the organizational processes and standards at the organizational level. So we have these frameworks that exist within the organization, but also we have standards and processes that exist on an international level or international standards, okay? And we're going to speak about that later on in the presentation. So some of the questions that the QA team or the quality and assurance team needs to ask themselves: has the software been thoroughly tested and does it show all the requirements needed? So this is more like a checklist that the Q&A team will work with. And they're looking, definitely that's going to be the first points they're looking at. Let's compare the documentation to what was delivered. Okay, does it show all the requirements specified? Does the actual solution that was delivered show the requirements? Is the software sufficiently dependable to be put in use? Okay, the aspect of dependability, can we trust it? Okay, what is the availability, accessibility of this software? Those are all of the components or factors that they use to measure dependability. Is the software user-friendly or usable? Usually this one, people tend to think that it's the main points that you actually look out for in terms of measuring quality, user-friendly and usability. So because you looked at the software and you didn't agree with the design, so then you classify it as not being quality, okay? So user-friendly and usability is one of the factors we use, but it's definitely not the main one, okay? As they say, don't judge a book by its cover, okay? So it's not about really how the software looks, it's about what was promised and what is eventually delivered. Can anyone understand the software and is it well structured? Okay, so you have to deliver a solution that is familiar with users that you are targeting, and also it must be able to follow a proper structure in terms of navigation and navigation menus and so forth. Is the performance of the software acceptable for normal use? Definitely a measure of quality. Besides how the software looks and what kind of features it has, then your next review would be based on performance. Okay, yes, there are all of these wonderful features that were promised and they work, but to what extent do they work? What is the nature of the performance? If I click on a button and I get the information after 5 minutes, then I cannot categorize that software as of being quality. Have programming and documentation standards been followed in the development process? Okay, so the other thing that the development team will look for is what the standards followed. You delivered the product on time, but did you follow the standards? Okay, standards are everything, and I'll tell you why later on. So the following are characteristics of software quality attributes. And as you can see, there is a wide variety of them. Some of them you're familiar with because they form part of our FERPs, non-functional requirements. So security, safety, reliability, resilience, robustness, understandability, and so forth. And you can see that these have nothing to do with the features. Okay, so what we can take from this slide is we can say that software quality is mostly measured based on non-functional requirements than it is the functional requirements. Okay, so it's mostly based on the non-functional attributes of the software. Is it secure? Is it safe to use? Is it reliable? Is it resilient? And so forth. So the team, the software, in terms of software quality, the team should also review the tests carried out by the development team and examine the results to check whether proper tests were conducted. Usually you can pick out deviations from requirements or errors or bugs through your testing process. So if testing was not done properly as part of your software development phases or life cycle, then you're bound to miss certain or critical details or not be able to detect bugs earlier on. So testing is very important part in that software quality. Quality of the software is mostly based on non-functional requirements. This is done as a way of reflecting practical user experience. Okay, so not really about what features are there. It's very easy to build features. Okay, you just look at when you're building features, you just follow a plan. But non-functional requirements, things that the user doesn't really interact with, but they expect them there. You know, you build this great feature, but when it's working, it's capturing or it's retrieving the data after X amount of time. So those are the kind of things that frustrate users, and the users end up not using the system at all, even if it has all of these great features which are coded to work in terms of functionality. Also, software quality attributes listed earlier mainly focus on usability, efficiency, dependability, and maintainability. So we have something that we call process-based quality. So the quality of the products that you produce or the software you produce is only as good as the process that you use to produce it. So let's say, for example, you favor the waterfall model in your organization. It's the process that you use to develop software, and you've adopted this as the organization. So the process that you use, that waterfall that you use, and all of its associated phases would be judged on the product that it produces. Okay, so you define, as an organization, you define your processes. You use your processes to develop a product. Then you look at the output or assess the product quality that is produced by your processes. If you are happy and you agree with the quality, then what do? You standardize those processes, which means we agree that this works, so we're adopting it as the main software development process for our organization. But if it doesn't, then you need to go back. So you can see that even adopting a proper process is an iterative thing, and you assess it based on the results that it produces. So we have process-based quality, and we are saying that the quality of the product produced is only as good as the process that is used to build it. And when it comes to software standards, during software planning, software standards must be considered when conducting quality assurance. There are processes, tools, and methods which must be used to ensure that certain standards are met on the system. What do we mean by standards? Standards can be at organizational level, as you saw in the previous slide. So we've adopted these things in the organization because they've been proven, we've measured them, we've seen the results that they're producing, so they've been proven to work for us. So we can have organizational level standards. Then we can have standards in terms of the country that we are in, okay, and the country that we're operating in. What kind of standards do they expect, okay? And if you look at the construction industry, in software, in terms of software, it's mostly governed by international standards, what is done internationally. But if you look at construction, construction is very unique in the sense that how you build a house in South Africa and how you build a house in the US, it will conform to different standards. The windows used, the way you build the walls and stuff like that. We have different standards. The wall plugs, there's different standards. So to some extent, standards also exist in terms of the country that you are in. But then we also have standards at an international level, which means they've been defined by an organization which we refer to as the ISO, International Organization of Standards. Okay, so they have, I know it's pronounced that way, even though it's abbreviated as ISO. So we have ISO, and they define the standards for most disciplines, not just only in software, but most disciplines that define the standards of how things should be done. So when we talk about standards, we're talking about adopting a process, okay, agreeing on tools, agreeing on methods to develop software. We know as an organization, we specialize on Microsoft products, which means maybe as an organization, our standard tool for developing software would be Visual Studio. So you have to make sure that our development team has access to all the Microsoft-based tools to develop software, because we're making use of Visual Studio. Okay, so standards is something that we adopt, and sometimes we have to be compliant in terms of country and international standards. Why are standards crucial to quality assurance? They say that standards capture wisdom. In other words, they capture or emphasize value in the organization. If standards are not properly specified, there is continuity in a project, since all software engineers will be using well-known quality. So if the standards are properly defined, okay, so there's going to be continuity, because everyone will have an understanding of what needs to be done and what needs to be delivered at the end. Everybody will have an idea, because we're all working from this one generic guideline. Standards provide a framework which can be used to define quality in an organization. So when they say that these standards capture wisdom, what they actually mean is that you are using processes and guidelines that have been tried and tested. Okay, if something has not been adopted as a standard, it means it either failed its test or it has not been tried and tested in the market. So because a standard has been tried and tested, we say it captures wisdom, and so it definitely ensures quality, and it's crucial for quality assurance. So we tend to focus on two types of standards. We have product-based standards, and then we have process-based standards. Okay, so when we're looking at product standards, so product standard checks the actual document to ensure that it meets a certain standard, and some of the things to be checked can be the structure of the requirements in the document, and the document standards, and the coding standards, and so forth. So when we're talking about product standards, we're looking at how was this software documented? Is there actually any documentation? To what extent was the documentation done? Okay, we're looking at how the requirements were gathered, how were the requirements modeled. We're also looking at what are the coding standards, okay, because there are also coding standards, ways at which you code software, and looking for deviations in any of these components will help us to be able to measure product standards, okay, and also process standards. What SDLC was used. We know that the SDLCs that have been defined out there, such as the waterfall and VNV model, and waterfall, and they're applicable in certain scenarios. So process standards speak to what process was used to produce the software, and product standards are used to measure the product, specifically the coding used, the way it was documented initially, and so forth. So in terms of this international organization for standardization, it is an organization that defines standards for different disciplines, not just only in software. But if you're looking at ISO specifically for software, then ISO 9001 is one of the standards or frameworks. And they say that this is an international standard which is commonly used during development of quality management. The ISO 9001 was originally developed in 1987, and it applies to industries which develop and maintain software. So the OSO 9001 is a framework for developing software standards where general quality principles are set out. Also, quality processes are described in detail. Organizational standards are clearly defined which procedures to follow. So this ISO 9001 doesn't really tell you how to build software. Okay, it's not a framework that tells you how to build your software, but it tells you what to look out for to develop your own matured processes that will yield quality results. Okay, and you can see that in this following slides, it speaks to two things. It says, if you're going to be developing any project for a software project, you need to at least, in terms of your product delivery processes, you need to follow in terms of requirements gathering, consider business acquisition. What kind of things or requirements are you bringing out externally? Are you integrating multiple organizations or not? Design and development. Okay, so what you do pre-project and what you do post-project, and that's the main thing they're stressing here, is that if you are going to build quality processes for delivering software, you need to really consider what happens before, okay, in terms of you understanding your business or integrating different businesses together, designing the software, getting requirements from scratch from stakeholders, and developing the software. Then what do you do after? Do your processes cater for that? Because what happens after you deliver the solution is all about supporting the system, making sure that it's maintained in the long run, making sure that you're testing in a live environment, making sure that there's proper training and so forth for users. So something like this product delivery processes as defined by the ISO, you can take those and you can build your own processes, okay? You can adopt whatever SDLC model and you can restructure it to suit your organization. And also, they say you must consider the supporting processes, okay? Business management, understanding before building products, understanding the company's vision, goals, and objectives, and so forth. Supplier management, who are our suppliers? Okay, where do we get our stock from, and so forth. So which other companies are we closely related to? Configuration management, how do we manage change? Okay, how do we manage change? Who manages change? Okay, change can come in from the people that are originally working inside the project, but it can also come in from external stakeholders. Okay, so we need to find a way at which we manage this change and approve the change. And also inventory management. How do we manage or control our stock and so forth? So we're looking at all of these. You can see that, okay, it says consider supporting processes or business related things. Then consider your processes in the organization, and your processes might speak to what happens pre-project activity and support after the project has been delivered to a group of users. So ISO doesn't really tell you that use the waterfall, use the VNV model, use the spiral model to ensure quality. It doesn't say that. It only gives you a blueprint of things that you may need to consider when you're developing or adopting your own quality standards. And what they are showing here is that you will have an organizational quality manual, which you tend to use as a template to build different projects, okay? So as much as we have the organizational quality manual, but sometimes there is a need to sort of tailor our processes for specific projects, because the nature of the projects that you are given are different. So here and there, we may need to tweak certain things, okay? So we can't be saying that, okay, in terms of our processes, our quality plan only favors this SDLC model. It only favors these tools, okay? You cannot be that because the nature of the project and the specifications of the customers are different. Okay, so your manual must take that into your quality manual must take that into consideration, that our projects may have individual unique requirements, and hence here and there we may need to deviate from what has been adopted by the organization and inform a unique quality plan for each of these individual projects. And then you want to speak about quality reviews and inspections. Reviewing is normally carried out to identify omissions, errors, to look for potential problems and non-conformance to standards. So we have a review meeting, the people that are working with, that worked on the software, and we have also the QA team. So reviewing forms part of us. Let's review the code, let's review the software, let's go through everything again and see what we may have missed. So during the review process, user manuals and documentation may be reviewed for consistency. The review team makes an informal judgment concerning the level of quality of the project. So at the end of the review process, there's a decision that is made. It's either you conformed to the standards or you did not. There's no in between. Okay, it's either it's accepted or it's not accepted, the solution that you have delivered. So we have pre-review activities, and these involves what happens before the review meeting, what needs to happen building up to this review meeting. Well, you need to first gather an independent review team. Usually we choose people that are experts in the field. So maybe if we are reviewing a project that is built on Java, then we need to get people that are also developers, that are also Java developers. The main thing here is to get an independent opinion. And so we say the pre-review activities involve you gathering the team, setting up the team, you getting documentation and the solutions from the people that worked on the project. And also, it's also based on finding a venue. Where are we gonna actually conduct this review meeting? And then what happens during the review meeting? The author or developer of the software has to walk through the document with the review team. Okay, so the people that worked on the software goes through the documentation. Okay, so we're comparing the documentation and what was actually ultimately delivered. The reviewing team may supply errors, omissions, and departs from standards, and in actual fact, they supply written comments to the panel. Okay, so the review team then has an ability to put comments on the documentation to say, we feel like you did not meet this requirement to a certain extent, or you did it to a certain extent, and so forth. So they compare, and they put comments on the documentation. So that's why documentation is important. Even if you are being agile, there has to be at least some form of documentation out there. After the meeting, the chairperson must sign a record of comments and any recommended actions agreed during the review meeting. So at the end, we can say that the comments from this review team, although they are opinions, but at the same time, they become recommendations. Okay, so the person who's chairing the meeting will have to sign off these comments, and then obviously for the development team that originally worked on this project, we'll have a lot of work to do. Okay, and that forms part of our after review activities. Okay, so once the chairperson signs off these identified omissions or errors, it means the development team has to go and correct them, and then we have post-review activities must be carried out, and this involves error corrections and any improvements which may be done on the software. For all these actions to take place, management should decide whether there are enough resources to correct or fix the errors. Sometimes the nature of the changes that need to be made to much of an extent where it will cost us more it'll cost us as much as building a new software from scratch. So they really need to measure if there are enough resources. By resources, we're talking about money and also people. Okay, do we have enough human resources to actually fix the errors? After effecting all the changes, the review chairperson is supposed to check and verify whether all the comments have been actioned. So it doesn't mean now after the meeting, the team, the development team can sort of, use their own discretion and say, no, we're ignoring these comments, no, that the changes must still go back to the person who chaired the original meeting, and they are checking now and verifying whether all of those identified omissions have been rectified. Okay, so that's all about reviews and also program inspections. So inspections, peer reviews where team members collaborate to find bugs in the program, and this forms part of the verification and validation process. So in terms of inspection, you don't necessarily need an external independent opinion on this. It's something that you do as peers in the project. Okay, and we know pair programming allows for this, people to review each other's code. So when we are expecting, we're looking at for certain bugs or issues with the code as the project team. So team members check the source code line by line. They also examine the design models. Problems encountered will be highlighted for repair in due course. So some of the things that we look out for in terms of our inspections. Okay, we look for data faults. Okay, is there anything in the data that we're capturing? Is our software yielding the proper results in terms of the data that it's capturing? We're looking at control faults. Okay, our loop conditions and so forth. Input output faults. Okay, is this data being validated properly in terms of the input, and are the proper variables being captured? Okay, interface faults. Do all the functions and method calls have the correct number of parameters? Okay, do all the components integrate well together? Is there any incompatibility? Okay, is there a particular component that's hogging up most of the memory for itself, and so forth? Storage management faults. If a linked structure is modified, have all the links have been correctly reassigned? If dynamic storage is used, has space been allocated correctly? So partitioning of memory and usage of memory and secondary memory on the hard drive. Is there fair equal distribution of this storage between the different components? And exception management and faults. How is the software handling errors? Is it crashing, or is it giving the user a proper readable error message so that they know the difference between a bug and a user error? Okay, so all of these are some of the things that we look at when we are doing an inspection, and this is a peer-reviewed function. It's not something that we need really an external body to come in and inspect for us. Okay, so in conclusion, study unit 6, we talk about quality assurance, and quality assurance is being practiced by many organizations. There is a standard framework which is being used by most organizations, and this standard is an international standard, which is ISO 9001 framework, which sets out general quality principles. Quality processes are also described in detail, and policies and procedures are defined in detail. We also spoke about inspections, the importance of inspections and reviews, which are regularly done to ensure that standards are met and followed. Also, inspections and reviews are activities which can be used during program testing to verify and validate software processes. So most of our inspections actually happened during the testing phase of our processes. They're not a separate thing that is done on the side, as opposed to the review. Okay, so the review team needs to review the software and associated documents. The whole process is to ensure that errors and bugs are identified, and any problems or defects detected, the review team will discuss them during the review meeting, and then obviously they are rectified as part of the post-review meeting activities. Okay, so that is Unit 6, covering software quality management. Okay, so let me just